Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Maybe it's not a comet and not an asteroid, something else.
Since the emergence of the first interstellar in our solar system, scientists have conducted numerous experiments and theories about the object, but none are concrete enough to give insight into this strange object. Recently, Joe Rogan, the host of the popular Joe Rogan Experience podcast, and his guest, Avi Leob, have exposed new truths about Oumuamua, saying it is not what we think.
But Oumuamua could not have been made by us because it's faster than any rocket that we can launch.
What exactly is this object? Join us as we discuss the strange interstellar object, Oumuamua. The strange interstellar, Oumuamua. On January 16, 2021, Joe Rogan invited physicist Avi Leob to his show, The Joe Rogan Experience, to talk about the mysterious object detected in space. When asked why Leob thinks Oumuamua is from another civilization, he answered by saying the object is the first of its kind to visit the Earth's vicinity from outside the solar system, moving too fast to be bound to the sun. He continued by saying astronomers first thought that it might be an object in the solar system, or that it was probably a rock they had seen before, like comets or asteroids. But Avi carried on. There wasn't a cometary tail on Oumuamua, and he also revealed an extra push away from the sun, which is usually gotten from a cometary tail. The main question in Avi's mind is why Oumuamua showed an extra push when it had no cometary tail, which is what got him to start thinking, maybe it's not a comet or an asteroid, but something entirely else. The other weird thing about the object is that it changes its brightness by a factor of 10 every 8 hours it spins. This means that it has an extreme geometry. Leob hypothesizes that this very object is not a comet because, if it were, it would have lost 1/10 of its weight because of the excessive evaporation. Neither does it have any gas or dust behind it. Thinking hard, the only thing that came to his mind was that the object itself was being pushed by sunlight that was reflecting off its surface, which could be concluded from everything that scientists know about the object. But in order for that theory to work, the object needs to be very thin, like a sail. Referencing another object found in September 2020 that showed an extra push with no cometary tail, the astronomers named it 2020 SO, but when they estimated back in time, they found that it was from Earth. The object was a rocket booster from a lunar lander that was sent to space. It didn't show a push because it's a thin structure, but Oumuamua is not made by humans on Earth because it passed by just for a few months more quickly than any rocket that was launched. Hence, astronomers could chase it when it was receding away. Avi told Rogan this was how he thought Oumuamua might belong to another civilization, which later went viral and the public got interested in it. But he said his colleagues did not support the idea, and some of them even got upset. But he thinks that Oumuamua is a blessing, because whatever nature gives, people should learn new things from it, which he's trying to do. Leob thinks that because they do not want to leave their comfort zone, they are unwilling to accept other meanings of things, referencing how Galileo Galilei was put under house arrest because he said the Earth rotates around the sun, and also Giordano Bruno, an Italian cosmological theorist, who set ablaze because he said there are other stars that have other planets around them, and there may be life on those planets. But those statements he made, the church found offensive, which led to the fire. Leob has taken this case to the public with his book Extraterrestrial, the first sign of intelligent life beyond Earth, which is about Oumuamua's fundamental mysteries. This mysterious object gradually moved into our solar system from space, but how exactly did it get here in the first place? The emergence of Oumuamua. On October 19th, 2017, Pan-STARRS 1 saw an enigmatic visitor traveling across our solar system while using the Panoramic Survey Telescope and Fast Reaction System. Astronomers had no idea that years of careful observation would result in the solving of an intergalactic puzzle known as Oumuamua. Though mostly speculative, astronomers had predicted the possibility of interstellar objects such as Oumuamua. Thomas Zurbuchen, an associate administrator for NASA's Science and Mission Directorate, put it briefly in November 2017, saying, "Until this peculiar visitor arrived, they have been theorizing about the existence of such interstellar objects for decades, and this is the first time they have direct evidence of their existence. Oumuamua set itself apart from other known space objects with its astonishing speed, traveling at an outrageous velocity of approximately 25,000 miles per hour. It has already outpaced other celestial bodies within our solar system. But the most fascinating part of Oumuamua's journey remained to be discovered. Oumuamua successfully completed a slingshot orbit around the Sun on September 9th, 2017, accelerating itself at a startling 196,000 miles per hour. Having witnessed it firsthand, its incredible speed begged many questions and left little space for doubt. After Oumuamua was first spotted, space organizations all around the world grabbed their telescopes to examine the orbit, brightness, and color of this unexplained object. Investigating Oumuamua's peculiarities, researchers even used the Very Large Telescope of the European Southern Observatory in Chile. In the meantime, SETI Institute scientists started scanning the object's radio emissions for any possible signals. There have been questions raised. Why is it called that name? And what is the origin of the name? How Oumuamua got its name? The object was officially named 1I 2017 U1 by the International Astronomical Union, which is responsible for granting official names to bodies in the solar system and beyond. In addition to the technical name, the Pan-STARRS team dubbed it Oumuamua, which is Hawaiian for a messenger from afar, arriving first. As the first known object of its type, Oumuamua presented a unique case for the International Astronomical Union, which assigns designations for astronomical objects. Other studies have also noted that star systems like our own would be more likely to eject comets than asteroids. But with no clarity on the object's nature, a new designation was created, I, for interstellar object. As the first object so identified, Oumuamua was designated 1I, with rules for the eligibility of objects for I numbers and the names to be assigned to these interstellar objects yet to be codified. Future observatories like the National Science Foundation-funded Large Synoptic Survey Telescope could help scientists spot more of these objects and improve our statistical understanding of planet and planetesimal formation, even beyond our solar system. Even though this object was flying through our solar system, it does have implications for extrasolar planets and finding other Earths, which might have inspired its name, Oumuamua Scout. You reach out for, and Mua, reduplicated for emphasis first, in advance of, and reflects the way the object is like a scout or messenger sent from the distant past to reach out to humanity. It roughly translates to first distant messenger. Before the official name was decided, Rama was suggested, the name given to an alien spacecraft discovered under similar circumstances. It has a rotation rate similar to that of solar system asteroids, but many valid models permit it to be unusually more elongated than all but a few other natural bodies observed in the solar system. This feature raised speculations about its origin. Its light curve, assuming little systematic error, presents its motion as tumbling rather than spinning and moving sufficiently fast relative to the Sun that it is likely of an extrasolar origin. Extrapolated and without further deceleration, its path cannot be captured into a solar orbit, so it will eventually leave the solar system and continue into interstellar space. Its planetary system of origin and age are unknown. Oumuamua would be remarkable for its extrasolar origin, high obliqueness, and observed acceleration without an apparent coma. By July 2019, most astronomers concluded that it was a natural object, but its exact characterization is contentious, given the limited observation window. While an unconsolidated object would require Oumuamua to be of a density similar to rocky asteroids, a small amount of internal strength similar to icy comets would allow it to have a relatively low density. The proposed explanations of its origin include the remnant of a disintegrated rogue comet, or a piece of an exoplanet rich in nitrogen ice, similar to Pluto. On March 22, 2023, astronomers proposed the observed acceleration was due to the release of entrapped molecular hydrogen that formed through energetic processing of an H2O-rich icy body, consistent with Oumuamua being an interstellar comet, originating as a planetesimal relic, broadly similar to solar system comets. Avi Leob has suggested that it could be a product of extraterrestrial technology, but there is insufficient evidence to support any hypotheses, despite all its strangeness. Could Oumuamua be an alien technology? This first interstellar traveler, which has raised many questions since it was discovered, differs from other known objects of celestial origin. It has very unique features that set it apart from typical celestial objects. At first, there were just two speculations regarding the nature of the object. The first was that it was an asteroid, and the second was that it was a comet. However, scientists have cleared up that doubt and clarified that it is not an asteroid. This results from its elongated shape and rapid rotation, unlike an asteroid. Also, its brightness fluctuated significantly as it traveled through space, and this indicates that it has a non-uniform surface. When mankind cannot find an explanation for a phenomenon in one way, they look for other ways to explain it and satisfy their curiosity. Within the scientific community, these anomalies depicted by Oumuamua raised a lot of eyebrows, and since they could not be explained using conventional means, it prompted some to consider alternative explanations for their existence, including their possible extraterrestrial origins. Of all the facts that could point to the extraterrestrial nature of the object, perhaps one of the most compelling arguments for the extraterrestrial origins of Oumuamua is the unexpected and unexplained sudden acceleration experienced as it passed through our solar system. It was traveling at 54 miles per second. There are many questions, but scientists still need to be more knowledgeable to find answers to those questions. Even so, there are no satisfying explanations regarding the acceleration. It could not be attributed to gravitational forces alone, and this has led astronomers to come up with the hypothesis that it might be propelled by solar radiation pressure. The problem here is that, though this phenomenon is not unheard of, it is possible for something to be propelled by solar radiation pressure. However, the magnitude and speed at which Oumuamua accelerated was just too much. It was far greater than expected, and of course, it had further increased the number of questions about its true nature. Of all the arguments for the possible extraterrestrial origins and nature of Oumuamua, the most fascinating one has nothing to do with its size or shape, but is about its intergalactic trajectory. The space object holds the record for being the first known interstellar object to pass through our space. How does this concern extraterrestrial activities? Scientists have clarified that the likelihood of a naturally occurring intergalactic object entering our solar system at the right trajectory to be observed is maybe 0 points or something percent, because the chances are extremely low. However, this Oumuamua entered our solar system at the perfect trajectory to be observed, even though it moved at an insane speed. This is why some supporters of the extraterrestrial hypothesis propose that the object could be a probe, or maybe even a spacecraft, sent to monitor Earth by an advanced alien civilization. If it turns out that Oumuamua is of alien origins, its possibilities would simply be limitless. It would represent a very significant discovery, one of the greatest, if not the greatest, discoveries of mankind. It would have profound implications for our understanding of the universe. Man is a curious being by nature. The possibility of an advanced alien civilization capable of intergalactic travel raises many questions about the scope and advancement of their technology and their motivation. This question kept bothering astronomers. Where is this strange object from? And how did it get here? The origin of the first interstellar object. Nobody knows which star system Oumuamua originated from. However, astronomers tracked Oumuamua back along the path from which it first approached the Sun and found that the object passed near 4 stars, coming closest to the red dwarf star HIP 3757 a million years ago. Our galaxy contains hundreds of billions of stars. Now, however, a new study narrows things down a bit. It concludes that Oumuamua probably came from a binary star. Binary stars are systems in which 2 stars are in orbit around one another. Together with systems containing 3 or more stars, they make up about 1/3 of the stars in the galaxy. Alan Jackson, of the University of Toronto at Scarborough, Canada, and collaborators used computer models to find that rocky objects like Oumuamua are far more likely to come from binary than single-star systems. They found that single-star systems, like the Sun, are better at ejecting icy comets than asteroids. This is because the comets live much further from the Sun and are therefore more weakly bound by gravity than the nearer asteroids. In a binary star system, however, there are stronger gravitational fields at play because of the 2 stars orbiting each other. According to the new work, these would be sufficient to eject as many asteroids as comets into interstellar space. Asteroids in our own solar system are valued as leftovers from the formation of the planets around 4.5 billion years ago. As such, they act as time capsules, preserving the conditions in which Earth formed. With Oumuamua, astronomers have seen one that relates to a whole different star system. It's remarkable that we've now seen for the first time a physical object from outside our solar system, says lead author Jackson. It was roughly 400 meters long and composed predominantly of rocky material. It reflected just 4% of the light that fell on it, making it as dark as asphalt. Although devoid of ice, it was covered in the kind of organic molecules that are thought to be the building blocks of life. It may also be the tip of a celestial iceberg. An earlier study by another group of astronomers, led by David Jewett of the University of California, Los Angeles, estimated that another 10,000 interstellar asteroids could be closer to the Sun than the eighth planet Neptune, which lies 30 times further from the Sun than the Earth. Yet these are currently undetected. A NASA animation describes how the object's path was hyperbolic, meaning it came hurtling toward the Sun fast enough that the Sun's gravity could bend Oumuamua's path only slightly, rather than capturing it in a looping orbit. This meant that Oumuamua, which was traveling at 16.36 miles per second relative to the Sun's motion, could just keep on going, heading toward the solar system's exit door. As there are extraterrestrial theories about Oumuamua, there are also theories about it being part of a much bigger celestial body. More hypotheses about Oumuamua. If there is one thing that scientists disapprove of, it is ignorance. It is clear that the most fascinating theory, the one that kept people on the edge of their seats waiting for the next news, was that Oumuamua was an alien probe or spaceship. Nonetheless, scientists have taken a very thoughtful and cautious approach, aware of the consequences. They kept looking for natural explanations for the unusual thing. The idea that Oumuamua is most likely merely a piece of an asteroid or comet, indicating that the item originated from a larger celestial body within another star system, is one of the natural answers they came up with. It is important to note that it is common for comets and asteroids in the vast expanse of space. According to scientists, comets and asteroids ate the remnants of the early formation stages of planets. They are made of rocks, metals, ice, water, and various compounds. On a side note, it's surprising that asteroids have water and ice. When these asteroids and comets collide with one another, or other space dwellers, they often break into smaller fragments, from which our space guest, Oumuamua, is believed to have originated. It is believed to have come from a much larger comet or asteroid, and something, maybe a collision, caused it to fall apart from this larger object. It then traveled through space and ended up in our solar system. As to why it didn't release gas and leave a trail when it was approaching the Sun, they explained that the gaseous substances that would have caused outgassing were already depleted or located in the object's sealed interior. Another natural explanation proposed to explain the unique behavior of the object is what is known as the solar sail hypothesis. The theory suggests that Oumuamua could be a flat and thin object, a few meters wide and less than a milliliter in thickness, so it looks a bit like a sail. This structure would therefore have a highly reflective surface. So when it passed close to the Sun, it would be subject to its intense radiation, and as sunlight photons hit the reflective surface, they impacted it with a tiny amount of momentum. When countless photons hit simultaneously, they can cause the solar sail to accelerate and deviate from a purely gravitational trajectory. If this theory is true, it would explain why Oumuamua suddenly sped up when it passed through our solar system. The solar sail theory is quite interesting, as it addresses all the issues surrounding our visitors. Another interesting thing about the theory is that it would not produce a visible comet-like tail, as there is no outgassing of volatile materials. Instead, the push is generated through the reflection of sunlight. However, the solar sail theory has its challenges. While it is very intriguing, it does come with its own constraints. One of the biggest challenges it faces is that it needs an explanation of Oumuamua's rotation, shape, and tumbling motion. These features would need to be explained in the context of solar sails. Also, it needs to be clarified how a solar sail of such dimensions could maintain its structural integrity under the enormous stress of interstellar travel. Seeing the shortcomings of the solar sail theory, another theory emerged. called the hydrogen iceberg hypothesis. This theory suggests that Oumuamua could be a celestial body composed of frozen hydrogen because hydrogen is the most abundant element in the universe and can exist in a solid state at extremely low temperatures and under pressure. Thus, this theory suggests that Oumuamua might have originated from an extremely cold, distant region of its home star system. In that environment, hydrogen could have frozen into a solid, forming a dense and compact object. If this hypothesis were true, and Oumuamua is indeed composed of hydrogen, it would have a very low temperature, probably close to absolute zero, explaining why it left no cometh-like tail as it approached the sun. So, how did the hydrogen accelerate Oumuamua? According to this hypothesis, the acceleration is attributed to the object's interaction with solar radiation. This means that although hydrogen is transparent to visible light, it can interact with higher energy ultraviolet and X-ray radiation. The absorption and re-emission of these high-energy photons could generate a thrust. The thrust is small but consistent, and it causes the object to accelerate. This interstellar object has been traveling for billions of years before it was sighted on Earth, and it has not stopped traveling since then. So, this has been raising questions about the whereabouts of the interstellar object and where it is now. Where is Oumuamua now? Oumuamua was not discovered by astronomers until it had advanced far enough into our solar system. On September 9, 2017, it achieved perihelion, the point at which it is closest to the Sun, coming within 23 million miles of our star. After more than a month, on October 19, 2017, Rob Warwick, an astronomer at the University of Hawaii, made the discovery of Oumuamua through observations taken with the Asteroid-Hunting Panoramic Survey Telescope and Rapid Response System PAN-STARRS. At that time, Oumuamua was 21 million miles from Earth, and its trajectory eventually brought it as close as 15 million miles. Ever since then, the interstellar visitor has been heading out of the solar system, with NASA describing how Oumuamua was accelerated by a gravity assist from the Sun to a velocity of 54.2 miles per second. Oumuamua was only visible for a few weeks due to its small size and rapid motion away from Earth, with the Hubble Space Telescope being able to track it for the longest. Even with the greatest photographs, Oumuamua may appear as a mere dot. One such image was created by merging data from the Very Large Telescope and the Gemini South Telescope, both located in Chile and among the largest optical telescopes in the world. Oumuamua is heading toward the constellation Pegasus and is now far beyond the orbit of Neptune. It is passing through the Kuiper Belt, a ring of icy bodies near the edge of the solar system, and is now beyond the reach of our telescopes. It will never come back toward Earth. Oumuamua was not the only interstellar object that was discovered by astronomers. This object was seen and was soon confirmed to be an interstellar comet, the Rouge Comet 2I or Borisov. 2I or Borisov has a heliocentric orbital abnormality of 3.36 and is not bound to the Sun. The comet passed through the ecliptic of the solar system at the end of October 2019 and made its closest approach to the Sun at just over 2 AU on December 8, 2019. The comet passed closest to Earth on December 28, 2019. In November 2019, astronomers from Yale University said that the comet's tail was 14 times the size of Earth and stated, "It's humbling to realize how small Earth is next to this visitor from another solar system." In the middle of March 2020, the comet was observed to fragment, and later, in April, even more evidence of fragmentation was reported. Unlike Oumuamua, which had an asteroidal appearance, 2I Borisov's nucleus is surrounded by a coma, a cloud of dust and gas. Early estimates of the nucleus 2I Borisov diameter have ranged from 1.4 to 16 kilometers. 2I Borisov has, unlike solar system comets, noticeably shrunk during a solar system flyby, losing at least 0.4% of its mass before perihelion. Also, the amplitude of non-gravitational acceleration places an upper limit of 0.4 kilometers on nucleus size, consistent with a previous Hubble Space Telescope upper limit of 0.5 kilometers. The comet did not come much closer to Earth than 300 million kilometers, which prevents using radar to directly determine its size and shape. This could be done using the occultation of a star by 2Y/Borisov. but an occultation would be difficult to predict, requiring a precise determination of its orbit, and the detection would necessitate a network of small telescopes. A study using observations from Hubble could not find a variation in the light curve. According to this study, the rotational period must be longer than 10 hours. A study with CSA's NEOSat found a period of 13.2 plus minus 0.2 days, which is unlikely to be the nuclear spin. Monte Carlo simulations based on the available orbit determinations suggest that the equatorial obliquity of 2I Borisov could be about 59 degrees or 90 degrees. The latter is favored for the latest orbit determination. Oumuamua appeared to be a rock. Borisov is really active, more like a normal comet. It's a puzzle why these two are so different. Other comets come mostly from two places: the Kuiper Belt, a donut-shaped region filled with icy bodies beyond the orbit of Neptune, or from the Oort cloud, the most distant region of our solar system, beginning some 100,000 astronomical units from the Sun, which contains billions of comets orbiting in a spherical shell. What do you think about this strange object? Don't forget to like, share, and subscribe to the channel for more interesting videos. Thanks for watching.